Hi everyone, Assalamualaikum. In this video, we are going to continue with volume by this. Now we look at example 3a. The shaded region in the figure below is bounded by the curve y equals to x squared over 4. The line x equals to 2 and the x-axis here. Using this method, find the volume of the solid obtained when the shaded region is revolved about the x-axis here, right? From the given question, the axis of rotation is x-axis, okay, here, okay? This is rotation symbol, okay? Alright, note that x-axis means line y equals to 0 and y-axis means line x equals to 0. Okay. To solve this method, okay, we need to write x-axis equals to line y equals to 0. Okay. And after rotation, okay, we get this diagram. Okay. Y equals to 0 here means x-axis. Okay, this is axis of rotation. Okay, this is the given curve. Okay, and the distance between curve and axis of rotation is called radius. Alright, and x-axis, the values of x-axis for the shaded region is from 0 to 2. Alright. From the given diagram here, okay, there is no gap between the shaded region and the axis of rotation. Okay, so after rotation, we will have solid object. Alright, because there is no gap between the shaded region here and the axis of rotation. Alright. Alright, when we use this method, first we need to find radius. Okay, since radius means the distance between the curve and the axis of rotation, so we can write in modular symbol. Okay, radius equals to curve or line minus axis of rotation. Okay, so we get radius equals to curve or line, we replace by x squared over 4. Okay, we replace from here. And then minus axis of rotation, we replace by 0 here. Then we put here. Okay. Notice that from the equation, y is a subject. Okay, so we can subtract. Right? So after we substitute here, so we get x squared over 4 for curve or line and then minus 0. Okay, axis of rotation. Alright. Right, then we can simplify radius equals to x squared over 4. Right? After that, we can set up volume by this formula. Okay, which is equals to pi and then we integrate radius squared. Okay, then we compare with the axis of rotation, which is x-axis or horizontal line. Okay, when axis of rotation is a horizontal line, okay, we need to integrate with respect to x. Okay, and when we integrate with respect to x, we need to use limit on x-axis. Okay, so our lower limit, okay, x equals to 0. Okay, our upper limit, x equals to 2. Okay, and after that, we have pi and then integration from 0 to 2, we replace radius, okay, equals to x squared over 4. And we still have squared here. Okay. Alright, when we use this method, if the axis of rotation is parallel to x-axis, here, horizontal line, okay, all term must in terms of variable x, including lower limit and upper limit must on the x-axis. Right? From the previous slide, okay, after rotation, after revolve about the x-axis, we get this diagram, okay, which is solid object, okay. We can use this method when we get solid object after the rotation, okay. From the previous slide, we also find radius, okay, radius equals to x squared over 4, okay. Then we can set up volume by this formula, okay. Alright. From volume by this, okay, equals to pi, and then we integrate lower limit x equals to 0 to upper limit x equals to 2 radius squared dx, because the axis of rotation is horizontal line, right? Then we replace radius equals to x squared over 4. Then we have bracket squared here. Okay, we integrate from 0 to 2 with respect to x. Okay. Alright. So radius here, we write in terms of variable x. All must in terms of variable x if the axis of rotation is parallel to x-axis. Right? And after that, we simplify from here. Okay. Then we get volume by this equals to pi. We integrate from 0 to 2. And then we simplify here. We get x to the power of 4 over 16. Okay. And then we can move out constant 6 over 16 here. So we get pi over 16. Integration from 0 to 2. And then x to the power of 4 dx. Right? So from here, we can integrate with respect to x. Okay. Then we get volume by this equals to, we still have constant pi over 16 here. Then we integrate x to the power of 4 with respect to x. Okay. After we integrate x to the power of 4, we get x to the power of 5 over 5. Since this is definite integral, so no plus c, but we must put square bracket with lower and upper limit. Okay. Alright, after we integrate, no more integration sign. Alright. Alright, after that, we need to replace upper limit into variable x here. And then in between, minus. And then we replace lower limit into variable x here. So after we replace upper limit 2 into variable x here, so we get 32 over 5. And then in between is minus. After we replace 0 lower limit into variable x here, we get 0 here. Okay. Then we simplify, we get volume using this method equals to 2 over 5 pi, and then we must put unit cube. Right? So this is the final answer. Okay? We can check the final answer using Symbolab. Okay? We must use the correct syntax. Okay? We have pi here, and then integration from 0 to 2, and then we have function x squared over 4 bracket to the power of 2, and then dx. Okay? So after we use Symbolab, we get the final answer 2 pi over 5 here, or in decimal 1.25663 and something. Okay. Alright. From here, volume always positive. Okay. If we get volume negative, maybe we make mistake when we set up the formula, or maybe we make mistake when we integrate. Okay. Alright. So we get volume by this equals to 2 over 5 pi unit cube. We just leave the answer in fraction and pi. Okay. so that the value is more accurate. Alright? So this is the final answer. When the shaded region is revolved about the x-axis. Okay? Alright, now we look at example 3b. The shaded region in the figure below is bounded by the curve y equals to x squared over 4, the line x equals to 2, and the x-axis. Using this method, find the volume of the solid obtained when the shaded region is revolved about the line x equals to 2. Right? Example 3a and 3b are from the same shaded area, but the axis of rotation is different, right? We recall back from example 3a, we have axis of rotation at x-axis here, okay? Alright, but in example 3b here, okay, our axis of rotation at the line x equals to 2 here, okay? Right? This is the axis of rotation. Alright? Alright, since the axis of rotation now is a vertical line, so using this method, we recall back the formula. Okay? Under this method, if we have axis of rotation is a vertical line, so we need to integrate with respect to y. Okay? When we integrate with respect to y, we need to write radius in variable y. And to write radius in variable y, we need to write x as a subject, right? So from here, we need to write x as a subject, okay? Alright, when we write x as a subject, so we have x equals to 2 third y, okay? How we get this? Okay, from the given curve here, we have y equals to x squared over 4. Okay, to write x as a subject, first we need to cross multiply. So we get 4y equals to x squared. Okay, and then from here, to write x as a subject, we move squared to left hand side here. Okay, so we get square root. Okay, so we have x equals to square root of 4y. Okay, then we can simplify square root of 4 because square root of 4 is a perfect square. So we can write 2 here. Okay, then we still have third y here. So x equals to 2 third y. Okay, so we get this. Okay, we write x as a subject because the axis of rotation now is a vertical line. So using this method, if axis of rotation is a vertical line, so we need to integrate with respect to y. So that's why we need variable y, and then we need to write x as a subject, right? And when we use integration with respect to y, we need to use lower and upper limit on y-axis. Okay? So now we have y equals to 0 for lower limit here. Okay? Alright. Then we need to find the upper limit on y-axis. Okay? So to find the upper limit on y-axis, we substitute when x equals to 2, we substitute here. Okay, when x equals to 2, so we have 2 squared over 4. So we will get y equals to 1. Okay, so this is our upper limit and lower limit on y-axis. Okay, right. Alright, after rotation, after this shaded area is revolved about the line x equals to 2, then we get this diagram. Okay, this is axis of rotation. Okay, this is the given curve. We write x as a subject. Okay, from here. Okay, and then the distance between curve and axis of rotation is radius. Okay. Alright. And then the value of y for lower limit equals to 0 and upper limit equals to 1 here. Okay. And then from this diagram, okay, there is no gap between the shaded region here and the axis of rotation. Okay, there is no gap. Okay, so after rotation, we will get solid object. Okay, because there is no gap between this shaded area and axis of rotation here. Alright. And if we get solid object, okay, so we can use volume by this to find the formula, to find the volume. Okay. Alright. So from here, we need to find the radius. Okay. So radius means the distance between curve and axis of rotation. Right. So we can write radius equals to, since the radius is a distance, so we can write in modulus. Okay. Radius equals to modulus curve minus axis of rotation. Okay. Alright. So radius equals to, we replace curve, okay, equals to 2 zy, and then minus, and then we replace axis of rotation equals to 2. Okay, we replace here. Okay, note that now we write x as a subject. So from curve here we have x as a subject, and from axis of rotation we also have x as a subject. So that's why we can subtract. Alright, because we have same x here. Okay. Right. Then we have radius equals to 2 zy minus 2, or we can factorize 2, so we get 2 bracket zy minus 1. So this is our radius. Okay. Right. Then we can set up volume by this formula. Okay. Volume by this equals to pi integration of radius squared. Okay. Alright, now our axis of rotation is vertical line. So we need to integrate with respect to y. Okay. When we integrate with respect to y, we need to use lower limit on y-axis. Okay, so we have y equals to 0 here as our lower limit, and upper limit y equals to 1. Right? Right, then we have volume by this equals to pi, and then integrate from 0 to 1, and then we replace our radius, okay, equals to 2 zy minus 1, okay. We replace here, okay. Radius equals to 2 zy minus 1, okay. Alright, so this is after we set up, okay, volume by this. We have axis of rotation is a vertical line, okay. So we need to write all in terms of y, okay, when we use volume by this, right? From the previous slide, okay, we set up volume by this equals to pi, and then integration from y equals to 0 to y equals to 1 radius squared dy. Okay, then after we replace radius, so we get volume by this equals to pi integration from 0 to 1, and then we replace radius equals to 2 zy minus 1, and then bracket squared dy. Okay, from here, when we set up volume by this, okay, when axis of rotation is a vertical line, so all mass in terms of variable y. Alright? Alright, then we can expand here, okay. volume by this equals to pi. Integration from 0 to 1, 2 squared equals to 4. We can move out from bracket here. And then third y minus 1 bracket squared dy. Okay. Alright. From radius here, we have variable y. Okay. Since axis of rotation is a vertical line. Okay. Alright. From here, okay, we expand and simplify. Okay. We can move out constant 4 here. So we get 4 pi. Okay. Then we expand bracket third y minus 1. Okay, squared. Okay. So after we expand, so we get third y squared equals to y. And then minus 2 third y. We can write 2 third y equals to 2y to the power of half because we want to integrate. So that's why we write in terms of exponent. Okay, and then negative 1 here when we expand. Okay, so we get plus 1 here. Okay, so from here we can integrate with respect to y. Okay, we integrate 1 by 1 because in between is minus and plus sign. Okay. So we get volume by this equals to 4 pi. We integrate y with respect to y. So we get y squared over 2. And then minus, we have constant 2 in front here. And then we integrate y to the power of half using power rule. So we plus 1 from the original power. So half plus 1 equals to 3 over 2. So we get y to the power of 3 over 2. After that, we must divide by 3 over 2. Okay. Since we have fraction, divide by fraction, so we can change to multiplication. When we change to multiplication, over 3 over 2 here, we can exchange to multiplication of 2 over 3. Alright? That's why we get this. And then plus, we integrate 1 with respect to y, we get y. Okay, since this is definite integral, so we have no plus c here, but we need to write square bracket with lower and upper limit here, right? And then after we integrate, no more integration sign. Okay. Right, after that, we replace upper limit into variable y here. Okay, 1, the power of any value will equals to 1. So that's why we get 1 squared here. So we get half minus, this is 1. Okay, 1 to the power of any value equals to 1. So times 2 times 2 over 3. So we get 4 over 3 here and minus sign. And then we replace 1 here. So we get plus 1. Okay, and then we replace 0 into variable y. So we have 0 here. 0 times any values equals to 0. That's why we get 0 here. Okay. Then volume by this equals to, after we simplify all of this, okay, remember to multiply by 4 pi outside here. So we get 2 over 3 pi. And then for volume, we need to write unit and then cube here. For area, we need to write unit squared. But for volume, we need to write unit cube. Alright? We can check the answer using symbol lab. Okay? From here. Okay? After we set up the formula here, we can straightforward use symbol lab here. Okay? But we need to use the correct syntax. Okay? So we have pi here and then integration from 0 to 1. And then we have bracket 2 bracket third y minus 1 and then bracket squared dy. Okay? And then from here, after we press enter, so we get this answer. Okay? This is the final answer. Okay? From here. Alright, so from the final answer here, okay, we can see that the volume always positive. Alright? if we get volume or area in negative value, so maybe we make mistake when we set up the formula, or maybe we make mistake when we integrate here. Okay, right? And we just leave the answer in fraction and pi. Okay, because in fraction and pi is more accurate compared to in decimal here. Alright? Got it? This is the complete solution. Okay? Coming up next, volume by washers. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.